shortened version of the same talk in Cardiff. And in Paris, so I attended Saturday Paris conference in 2019. And I'm actually wearing the t-shirt from that conference, but you only see a black t-shirt, so you have to believe me. And today I will share some tools and tips around managing your art project. I had some slides introducing myself, but I don't need to go through them because I was introduced by John Matiso. And my slide deck is online. I've put the link in the Zoom chat. So it's Saturday-Nairobi-Maëlle.netlify.app. And the goals of my talk are, well, really the goal is that every one of you learns at least one new thing. And I have several sections. The first will be about basic principles for art projects and how to protect your projects from external changes, what structure to use for your project, and how to run your project. And why am I giving advice on art projects? So that's not, so the title of my talk is please run me a project. So in The Little Prince, the book, there is a quote where the Little Prince asks, please draw me a sheep. So that's not exactly what he asked for, like a project, not a sheep. But I think that advice on projects can really improve the life of anyone touching or reading your project, like someone reading the result, or you that needs to run the projects again in a few weeks. So this all helps reproducibility. It's also good because there is always something you can improve in your art projects, in the way you work with art. Sadly, it also means there is always something you can procrastinate on. So that's something we all need to be aware of. But sometimes we just need to do the work and not improve the workflow. And why listen to me? So I'm actually not regularly in charge of analysis, so that's a bad point for choosing this topic, but I try to keep up to date with our news, and this is how I gathered some tools and tips for this presentation. So starting with some basics doesn't mean it's easy. Basic means it's fundamental and very important, but these are all things to learn. And my main source of advice here is Jenny BRYAN. I identify with the quote by Charlotte Gelfand, who said, everything I know is from Jenny BRYAN. And just a note that Charlotte Gelfand said that after a talk, and Charlotte himself is a great source of information, so you could go watch this talk by Charlotte Gelfand, which was, don't repeat yourself, talk to yourself, repeated reporting is the art universe. But coming back to the phrase, everything I know is from Jenny BRYAN, it's something that enough people identify with, so that there is a logo, and on this logo, there is a computer on fire, and I will explain later why there is a computer on fire when there is this logo. When you start a new project in art, like maybe an analysis, scientific article, a report, you might think of your project as a garden where you really try to spend time caring for your flowers. But the bad thing with this analogy would be that you cannot really take a garden somewhere else. But I was very happy to see a tweet about a competition in Japan where people build beautiful gardens on little trucks. And that's really how I want my art projects to be, like beautiful, but also very portable. And so to come back to the idea of laptop on fire, during a talk, Jenny BRYAN said, if the first line of your script is either set WD, a path that's only on your computer, or RM, where the argument list is equal to ls, to everything, then Jenny BRYAN will come into your office and set your computer on fire. So this is quite scary, and in a blog post in particular, she explains how you could not do that. And so the first idea is that you should have fire paths that are relative to the root of your project. So for instance, if I add a CSV file in my Saturday Nairobi folder, and it's in the subfolder data, I shouldn't use reader read CSV and then all the path from home, mail, documents, conferences, Saturday Nairobi, because this structure of folders only exists on my computer. If I give you my Saturday Nairobi folder and you try to run the code, it will fail. And to also illustrate the idea, so Alison Horst, who makes a beautiful illustration of R packages and other things relating to R, made an illustration illustrating the here package. And on the left, you have a very scary path, like with spiders and set WD everywhere. On the right, you have a beautiful path with flowers and the here package. So what is this all about? So the here package is a package by Kirill Müller, and you need to use it to have something at the root of your project. Like if you use RStudio and our proj file, so you don't need to do anything. If you don't need use RStudio and you don't use Git, you can have a .here file as a project root, and it's an empty file. And once you have that, you can use the here function, and it gives you the path to something related to the root of your project. So in my Armageddon slides, I run here, and it gives me the path to my Saturday Nairobi folder on my computer. If I run here data, it gives me the path to the data folder of the Saturday Nairobi folder. So if I want to read the CSV file that's in the data folder in my Saturday folder, I can use here data cool stuff.csv, and this is really cool because it works from anywhere inside my Saturday Nairobi folder. So I can use this code in my maybe a README file that's at root, or maybe I have a subfolder with reports and a script, then it would work from there too. So it works on your computer, it would also work anywhere in my folder. And then how not to use RM list equal to ls. The idea is you should always start fresh. You should restart R regularly and without fear. If you somehow have the idea that there is something in your environment, maybe a package loaded, some object that would disappear if you restart R, and you're afraid of that, this means that you haven't written everything you should in your script, because the source code should be enough to recreate everything you want. And you should never save and reload the .r data, which you might know is a default setting in RStudio. So the default is a bad option, but there is a use this function to use this use blank slate function. So if you run this once on your computer, it sets your RStudio preference to never save or restore R data on exit startup. So that's a very good function to know about. And this two ideas, so the path using relative paths and restarting regularly. This is a project-oriented workflow, which is presented in particular in a blog post by Jenny BRYAN, and it's really a way of working that will change your life. And it pairs well with using the use this package, for instance, maybe creating projects with the use this create project function. Then, and so in Shakespeare, in Romeo and Juliet, in Shakespeare, there is this quote that we often see, that which we call a rose by any other name would smell as sweet. So this is a cool quote, but that's not true when you're writing code. So there is a slide deck by Jenny BRYAN with tips about naming your files, which is very useful. Your file name should be machine readable. So if your name is Maëlle, 2 dots on the E like me, you shouldn't name your files with your name. Then it should be human readable. So the idea is that when you see a file name, you as a human should have a basic idea of what's inside. And it should work well with default ordering. For instance, if you have dates in your file names, it's good to use year, month, day as a way to call them, because this way, when you order the files alphabetically, they are also ordered by time. Just to know that I can't see anyone, so everyone has their camera off. So if there's any problem, please tell me. Or if someone wants to turn the camera on, then that's a good idea. And also about naming things, so not only files, but also variables, for instance. When you want to write readable code, you try to use variable names that are sort of informative. And this week, Jenny BRYAN tweeted, "I didn't expect programming to involve so much time studying a thesaurus." So, and just a small public service announcement, please take time to think. If someone came and put your computer on fire, what would you lose? So hopefully you would only lose the machine, be a bit afraid, but you wouldn't lose all your files because you have a backup somewhere. So it's important to have a backup. But then not only with the idea of backup, your project will evolve over time. You're starting one day and then you're improving it. So how do you keep track of changes to be able to come back to your project at the given state, for instance? So to control the version, you have an approach that could be to have dates in file names, or something like adding final in the names of your files, or you could use version control. And the most popular tool for version control these days is Git. And learning Git is not easy, but it's worth it. And it's also not something specific to R, which is good. You could use it when you don't use R, but it's very useful when you are using R. And the idea with Git is that it allows you to try things out and to come back to a previous version and to understand past changes. So there is an XKCD comics by Random Runner about Git, where you have 3 people in front of a computer, and one person says, this is Git. It tracks collaborative work on projects through a beautiful distributed graph theory tree model. Another person asks, cool, how do we use it? And the first person answers, no idea, just memorize these shell commands and type them to sync up. If you get errors, save your work elsewhere, delete the project and download a fresh copy. So actually learning it is not always that awful, but the idea to delete the project and download a fresh copy, this sometimes happen when things go wrong. But more simply, so what is Git? So here is an illustration of several states of a sheep, like baby sheep, young sheep, adult sheep, and a box. And between them, there are arrows. And with Git, the idea is that you can save a snapshot of your files of your sheep at anytime you want, and you can see the difference between 2 states. And when you do the snapshot, so if you arrive at the young sheep state, you write an informative commit message such as put now the sheep is standing, or something like that, like something informative. So that's the idea of Git. And also the idea is that you can go from the young sheep here to the adult sheep or to the box. So you can explore different ways to do your project, and these are called branches in Git, but really that you can try different things and still have their state saved in the history. So here are some Git commands roughly explained. So with git add, you start tracking a file, and if there are files you never want to track, for instance, maybe files that contain some sort of secret, you could list them in the git ignore file. With git commit, you save a change in the history. With git pull and git push, you sync up your local version with some remote version, maybe a GitHub repository. And with git checkout -b, you create a branch, which is a way for you to explore before maybe deciding that this approach is indeed the best, or maybe that's not the best approach. And so good, but where do we use these git commands? So here I'm at preferences. Sometimes I don't even leave R to use git commands. So with the use this package, you can, for instance, start using Git in a project with this use Git function. You can create a GitHub repository with the use GitHub function. There is also the Gert package, that has lower level interface to Git. So with Gert, you can push, you can commit, you can pull. Then if you use RStudio, there is a Git window where you can click and you don't have to go too far away from R. Sometimes I use a command line for commands that I am either copy pasting from Stack Overflow or the rare commands that I know by heart. And I don't use a graphical interface for Git because maybe I never do anything complicated enough to need that. But you can use, for instance, Git Kraken, or I've been told by the Git interface in VS Code is very good. I've listed some resources about Git, and since my slides are online, I'm not going to describe them now. So until now, what we've learned from like Jenny BRYAN wisdom is to isolate our projects and to restart R regularly, to name files well, and to use version control. And I've also listed even more wisdom by Jenny BRYAN and collaborators. And now I wanted in this section to explain how to protect your project from external changes. So another scary story where no one is coming and setting your computer on fire. But imagine you have written beautiful data wrangling with a function called my favorite function from the package, and you update packages on your computer, you come back to your script and you realize that in the new version of package, there is no longer the my favorite function package. So this was actually a good idea by the package authors because they have another function that's better, but for you, it's bad news because you would need to update your script because it's now broken. And sometimes you don't have time to do that. You just want your script to keep working as it was. So the idea is that you can actually store project dependencies, like encapsulating your project, like having one set of package version for one given project and in another project using other package version. And an important tool for doing that is the RENV package by Kevin Ushee. It's the successor of Packrat by the same author. If you've used Packrat before, RENV does the same thing, but is better. So how do you use RENV in a project? It's actually very simple. So you start using it with the RENV init function. After that, you install and remove packages as you would normally. And what's a bit more difficult maybe is to remember to regularly run the function called snapshots, the RENV snapshot function. What this does is storing the metadata about the packages in a file called renv.log. So what is metadata of dependency? It means that in this file, all the packages that you use in the project are saved and their version and where they come from. So maybe it's version 1.0 from CRAN or it's version blah, blah, blah from GitHub. So these kind of things. And it means that if you take the folder with your project and you give it to your colleague or you give it to yourself on a new machine, to reinstall the correct versions of all packages, all you need to do is running the renv restore function. So that's very handy. Now, if you want to encapsulate even more things, so maybe you want to have a fixed version operating system, like everything, you might be interested in Docker. There is a good introduction to Docker by Colin Fay, and also recently there was at Our Ladies Brisbane a meetup about Docker by Maëlle Salmon. And this talk, Introduction to Using Docker for Reproducibility in R, has been recorded and materials are online. So in short, to protect your project from external changes, I'd recommend listing the dependency of the project, and the easiest way to get started is the RENV package. So now, what file structure to use for your project, how to tidy things up inside your project. So in your project, you probably have some data or either data or code that gets data from a database or some sort of website. Then you have some code that manages the data, fits a model to the data maybe, and you are willing to have some output, maybe that's a graph, a report, so that kind of things. Now, how do you tidy all these things? So the file structure for your project should be consistent. Hopefully you can start a new project automatically, and maybe you want that to look like a package or maybe not. There are many packages for creating projects, but one of them is a project template by Kenton White. I've never used it, but I really like the blog post Love for Project template by Hilary Packer, because the criteria she lists as reasons for liking this package are very good things to have in any package, in any tool that helps you with project structure. So she wrote, routine is your friend. It's easier to start somewhere and then customize rather than start from the ground up. Reproducibility should be as easy as possible. Finding things should also be as easy as possible. So that's all very good. And some debate that there is sometimes it should an analysis be an R package. And I will further list scenarios where it's a good idea to make an R package. So if you want to store functions and data that you are using in several projects, not only one, but several of them, then making an R package is an excellent idea. And there are many great resources out there to learn how to make an R package. In particular, the tutorial by Shia Kariuki that she gave at Our Ladies Nairobi recently, and the tutorial has been recorded and materials are online. Then maybe you can also make a package to store something like an RStudio project template, or maybe a package that has functions for recreating a project structure. So that's a good idea too, like without a doubt. Now, storing your project as a package, then that's a maybe. Maybe it's a good idea, maybe it's not. So what do I mean by analysis project as a package? The idea is that you would list dependencies in description, have the functions in the R folder, maybe documented in the man folder. You would have data maybe in the data folder or data row folder. Your analysis could be vignette, so R markdown files, and you could have an informative README. So that would be the basic structure. The advantages of using a package to store your analysis is that it allows you to either reuse or refresh your package development skills. And you could reuse tools that are made for package development like DevTools and use this. And this approach is the idea of a compendium and was in particular described in the paper Packaging Data Analytical Work Reproducibly Using R and Friends by Ben Marwick, Carl Böttiger, and Lincoln so in 2018, but maybe I already said the year. If you create your project as a package, there are specific tools that you can use. The R tools package by Ben Marwick can help you set up a new compendium. If you use the hole punch package by Kathy Graham with the so what it does is it interfaces the binder project. And if you use that, then you can add a badge to your to the README of your compendium, and it allows the reader to play with your code online in a new RStudio instance. It actually works without the compendium structure, but I think it's still meant to be used with compendiums. And if you also, so if you have your project as a package and your analyses are vignettes, and it's public, then you can use the RUniverse project by Jeroen Orms at OpenSci that will allow you to publish your analysis, because with RUniverse, you have the universe with all your packages and it renders the vignettes in one tab of that. Then that would be a way for you to have an URL to point people to when they want to read your analysis. Then there are still opponents to the idea of project as a package, in particular as a blog post project as an R package, an okay idea by Matt McBain. And in particular in this blog post what he wrote was, my response to advocates of project as a package is you are wasting precious time making the wrong packages. Instead of shoehorning your work into the package development domain with all the loss of fidelity that entails, why aren't you packaging tools that create a smooth DevTools use-based style experience for your own domain? So that's a bit harsh, but that's still good to keep in mind if you are hesitating what approach to use for your project. So to conclude on the file structure for your project, I think that what file structure you use is really up to you and your teammates, but it's important to have a basic structure that's consistent over time, and also to have a way to automatically create it. It could be some sort of project skeleton that you have somewhere and just copy paste when you start a new one. It could be as simple as that. And the idea is to make reproducibility easier. Now, how do you run your project? So you have your resources, you have your scripts, how do you get the analysis output? And of course, you could run code line by line, but that wouldn't be necessarily very handy to do that. So if your project is one or a few R Markdown reports, maybe all you need to do is a knit button, for instance, or the R Markdown render function, so running that regularly. But maybe you need something more complex. So I'm going to discuss two cases with one package for each case. So maybe you want to optimize a pipeline, or you want to track versions of an analysis, so at both the input and output. So to optimize a pipeline, I'm going to present the targets package by LANDAU, and to track version of an analysis over time, I'm going to present the orderly package by Rich Fitzjohn. So targets by LANDAU is a package that deduces a relationship between the pieces of your project. So say in your project you have raw data, you transform it into data, you fit the data with a model, and then you make a figure of the model fit. Then if you only change the model, you only need to redo the figure. You don't need to recompute the data from the raw data, and that kind of logic. So what needs to be rerun when something changes is something that target does for you. Targets only performs the necessary computation when you change something, and that can lead to a lot of of gain of resources and time. Targets is part of the RENV suite of packages, so it has been reviewed at RENV, and it's a successor of Drake by the same author. So how does it work? At the core of a targets project, of a targets folder, you have a file called _targets.r, and in that file that you write yourself, you can load packages. You can load functions. So if you've written function in the R folder, for instance, you can source this script, and you define targets. So what are targets? This is key to understand. So here is a targets definition in an example from the targets manual. So we have a list of targets. So first, so all of them use the target function to be defined. So first one, so it has a name, raw data file. Then there is the path to the file relative to the root of the project, and the argument format is set to file. So this one is a bit special. It tracks the raw data file. Then there is a target called raw data, and it's defined by our code, by the code read CSV with the path to the raw data file. Then we have our target called data, and it's defined by our code as well, also by filtering the raw data. And the filter function that is here comes from the dplyr package. The dplyr package has been loaded previously in the targets.r file. And there are two last targets, ist and fit, that are defined by our code that uses functions that are specific to the project. These functions have been sourced previously in the targets.r file. So this is how you would, so when you write a targets package, you define the different pieces and you write them in this list. So how does it run? So to build a targets package, you run the tar make function. If you need to destroy everything at some point, there is a function for that, the tar destroy function. And what's very useful with targets, well, many parts of this are useful, is that you can understand your pipeline with functions such as tar glimpse. So tar glimpse shows you a network of dependencies between the pieces of your project. So in the case of the example I've shown, you have the raw data file that becomes raw data, that becomes data, and data is used in fit and in the ist and target. And so it's a very simple one, but sometimes you see people sharing pipelines that are very complicated, and it's very cool to be able to visualize them this way. So how to get started with targets? So manual of targets. So it's a book done book. It's very well done. And there was, if you prefer learning with a video, so there was recently a talk by LANDAU at the user group of Lille about targets, and I would recommend starting with a small project. So I know that in my case, I read the manual, maybe I watched a video or two, but things became much clearer for me when I wrote a small target project, and that's really my current level. I'm not an advanced targets user. And targets is not a package on its own. There is a whole ecosystem of packages around targets. Targetopia, that has, for instance, a package for using targets with Stan, another one for using targets with JAGs. And how do you keep up with targets, given that it's a package that is developed very actively? So you could watch the Github repository of targets. You could follow LANDAU on Twitter. I would recommend subscribing to the RENV newsletter. I would recommend doing that anyway, because I not created, so it's a very good newsletter. And you should connect with other users to exchange ideas and questions. So now the orderly package by Rich Fitzjohn. So here the challenge is a bit different. What if you are writing a report about the situation of the pandemic in your region, and this report is used for making decision? It's very important in that case that you keep track of everything that has gone into your analysis at different point in time, so that if in 1 month from now someone is doing an audit, then, or yourself is doing an audit of what you've done in the past, you can see what you have done in the past, and with orderly you can even combine you can make an analysis of the analysis. So that's the idea behind orderly. So how does it work? So in orderly vocabulary, you have repos, and in repos you have reports. They are called reports, but then they are not necessarily reports. So it could be a script that generates figures and there is no report involved. But anyway, I've made an example of a report that has one report in it. So I was in an existing RStudio project. I run the orderly init function and I created the blob report. So blob is not an informative name, but that's the one I used. And then I created a report inside of the blob repo by using the orderly new function. And I added two files from the orderly documentation to have some sort of minimal example. So what I had was a blob folder with a general configuration, orderly config.yaml. That one I didn't need to edit to make things work. So it can be useful in some cases, but you don't necessarily have to edit that one. And then there is a as_lc folder, so the source folder with the example folder. So this is my report, and my report is very simple. It's only an orderly configuration, that one I need, and a script. So what is in the orderly configuration? So it can remind you of the targets.r file because it describes many things. So it describes the script that has to be run, and it describes the artifacts that my script is creating. So the artifacts are static graph and data. Each of them is described by words, like a graph of things, and by a file name. And the script, in that case, it's a very simple one. So it generates random data in a data frame. It writes this data frame to a file, mydata.csv, and it makes a plot of the data. So how do I run the project? How do I go from the script to the result? So first, in some cases, because with orderly, for instance, the report is in the subfolder, it might be hard to write the code. So you might want to experiment with the development mode that puts everything inside the current session. Then once you are fairly happy with what you've written, you can create a draft version of your report by using the orderly run function. And what this does is that it runs the analysis and it puts everything, so a copy of the input and output, in a folder inside the draft folder. So it's in draft, example, and some ID that's based on the time at which it was computed and a hash, I think, of the analysis. So this is a draft folder. If you're really happy with what you've done and you want to save this, you use the orderly commit function. So commit is the same verb as when using git. So when you use the orderly commit function, it puts a version of the analysis inside the archive folder. So your archive example and then some ID for this version. So something that is important to say here is that when you use orderly, maybe you have a huge analysis. So you are not expected to track archive and draft with Git, but with something else. You might need to have some sort of backup with a server or something like that. So how to get started with orderly? So the orderly documentation website is really great. So when you read it, I think that you can really see that it has been used for real. Like there are real people using the orderly package, and the orderly documentation shows how their experience has been used to improve both the package and the documentation. I would recommend starting small to understand how it works, because like it's again like with targets. You read, oh, pieces fits together, pipelines, and it's the same with orderly, like the idea of archive folder, draft folder. It's all much clearer when you run it once. And I would also recommend connecting with other users. And how to keep it, because as targets, orderly is actively developed. So you could watch orderly GitHub repository. You could follow the blog of the team that develops orderly. And it's actually a good blog to follow in general, because they have really great blog posts about R and programming in general. And you could follow Rich Fitzjohn on Twitter. So to conclude this section, how to run your project. So if you have only one or a few R Markdown reports, maybe you can use the knit button or the R Markdown render function. If you want to optimize the pipeline, I'd recommend checking out the targets package. And if you want to keep track of all versions of the analysis for future audits, for instance, the orderly package is a great package. And there are other tools that can help you create your running your project, and you could even create yours. And what's important also to say is that in this talk, I've presented the idea of the file structure and how to run your project as separate concerns. And I've presented packages here that are not opinionated about the file structure. Sometimes you will find R packages that help you do both, create the structure and run the project, and that are quite strict in how you structure your project. So to conclude the talk in general, first, I wanted to thank the organization team of Saturday in Nairobi. It was a pleasure to be invited and to meet some of you. And I also want to thank Christophe Dervieux, who reviewed the blog post I wrote with the content of this talk. So how do you draw a project? So it's important to know the good basics, like isolating your project, having backups. It's important to encapsulate the project, for instance, with the RENV package, to not have your script broken by package updates. The file structure of your project should be practical, consistent, and hopefully automatic. It doesn't need to look like a package. And I would recommend using tools for building outputs that are adapted to your needs, like for instance, optimizing a pipeline. I've listed some more resources on how to learn how to draw a project. And to really summarize in even less words, you should read everything that Jenny BRYAN wrote. You should choose or even create, like with your teammates, if you have teammates, like the box in which you put and build your project. So what file structure and what package do you use? And you should not be afraid to renew your tool set over time, because your taste and your needs will change. There will be new tools out there. But the good news is that if you are attending a conference, an R conference, you are probably not afraid to learn new things. So that's all from me. Thank you.